Okay, so it's time to talk about lighting. In this section, I'm going to go over different types of lights, different lighting terminology. I'll particularly focus on lights that are used in commercial and residential buildings. And finally, we'll go over how to perform a lighting analysis or lighting survey that will help us determine appropriate light levels in a building space. Okay, so the basic lighting types that you'll see in residential applications are going to be your incandescent, your CFL, and LED. And there are videos posted about each of these, so I'm not going to go over in too much detail. An incandescent, basically you just have this wire filament that gets really hot, and you write an electrical current through it. Whereas with the CFL, there is no wire in here. Okay, so this is a tube that's wrapped around in a spiral. Now they have linear fluorescents as well, and I'll go over that in a minute. But these are, they don't have any metal going through it, they just have a gas in there. So there's an argon gas. And basically when it has a ballast at the base here, and when you run an electrical current through it, what happens is the ballast converts the voltage and the current, and it excites the argon gas in here, and the argon gas emits UV light, which then hits the side of this. Okay, and there's this phosphorescent coating on the side, and then that actually projects the light out. I'll show you a little image of this in a minute. But there is, so with an incandescent, it's just hot metal. This is more heat than light. Whereas this, actually the gas molecules get excited, and they emit some ultraviolet radiation, which then hit the side, which then emits the light. So the whole thing lights up. And then the LED is a diode. So it's if you've ever seen an LED light, it's just they're little diodes. They're like little dots, maybe ½ an inch across, and they just emit photons out. And again, there's a video posted there. I'm not too worried. You don't need to understand the technology in any great detail. But you should know that with CFLs, there is a trace amount of mercury in there. And so if like an incandescent breaks, and an LED breaks, your biggest problem is that, if there's broken glass. Whereas with a CFL, you got to be careful. Because there is a little bit of mercury gas in there. And so if a fluorescent tube or a CFL breaks, you just need to air the room out for like ½ an hour, run the fan and or open up windows, excuse me, to air it out, and then just sweep it up and put it in a bag and throw it in the trash. So just a sort of a public service announcement there, that there is a little bit of mercury in there, so you have to be a little bit careful. So here's sort of a pulled apart CFL. So as I said, with the CFL, it actually has this thing called a ballast. So all fluorescent lamps need a ballast to operate. So the electrical current goes through this ballast, which is these electrical components. And you can see in here, there's that little argon gas, and there's mercury vapor in there. Sorry. And so when you expose this to high voltage, these little molecules get excited and they emit UV radiation, which then hits the side here, and then the side lights up. Okay, so all fluorescents need a ballast. So linear fluorescents, which are really, really common in commercial buildings, it's the same principle, right? So you have the gas, the argon, mercury gas in here. Actually, it's liquid mercury and argon gas, but it's the same thing. You have to have a ballast. Now in a ballast, it's in one of these linear fluorescents, it's separate. Okay, so it looks something like this, and it'll be kind of tucked in above the lights up here. And so you run the current through there, and that excites the gas that hits the side of the tube. That gets excited, emits light, and that's how that actually generates light. So some important terms, and I did put this in the lesson this week. So energy managers and lighting designers refer to what we normally call bulbs. They call them lamps. Okay, so this is and this would be a luminaire is the proper term for that, but some people call it fixture. So a fixture or a luminaire just holds a number of lamps, or it could hold a single lamp, right? Like you could have a single a luminaire in the ceiling, Actually, you might be able to see it, but I have these little luminaires up here that have single lamps in them. That's still a luminaire. Okay, it holds the lamp. So this luminaire has 4 lamps, or this is a 4-lamp fixture. Okay, so that's really important to use the right terminology. And there are actually different types of fluorescents, fluorescent tubes. So we have T5, T8, and T12. The T12 is 1.5 inches in diameter, as you can see here. The T8 is 1 inch in diameter, and the T5 is 5/8 of an inch. If you want to know just where the name comes from, T5 is 5/8 of an inch, or 0.625 inches. T8 is 8/8 of an inch, or 1 inch, and T12 is 12/8 of an inch in diameter, or 1.5 inches. Don't ask me why. That makes no sense to me, but at least there is some logic to it. So the T12s are the big fat tubes that you see in like old buildings. They're the least efficient out of the 3. T8 is more efficient, and T5 is the most efficient. And generally speaking, these are not interchangeable. So if you want to go from a T12 to a T5 or a T12 to a T8, you're going to need to change the whole luminaire. So these are actually at this point almost passé, because LED tubes have really taken over now, and so now they make these tubes that look like fluorescent tubes, but they're actually full of LEDs. And you can see this is exploded, or you can kind of see inside this tube. You can see that there's all these little diodes. Each of these is a diode. Okay, little dots. And these are great. These are much more efficient, twice as efficient as over twice as efficient as T12s and T8s. They do make some plug-and-play ones where you can actually just pop out the old fluorescent and pop in the new LED. Now an LED, remember that a fluorescent needs a ballast. Okay, so any fluorescent light needs a ballast. An LED tube, or any LED for that matter, needs a driver. Okay, so a driver, not a ballast. And this is an important consideration. If you have these plug-and-play LEDs where you just pop out the fluorescent, pop in the LED, that means that the electricity is still flowing through that ballast, right? So this thing here is still, electricity is still going through there before it gets to the LED, which is totally fine, except for one really big problem. That ballast is probably going to burn out before the LED tube burns out. And so it can cause some issues if you do the plug and play. It's the easiest solution. You just pop them out, pop them in. Whereas the type B, what you do is you just go above and just basically circumvent the ballast, and you just rewire the light. So you skip the ballast entirely. And so that way, if the ballast burns out, or well, the ballast won't burn out, but you skip the ballast entirely, so you don't have to worry about the ballast burning out. So all of this is to say, LEDs are the most efficient, and this is what everyone's going to LEDs because they're so efficient, they're so flexible, they can make them in any shape now, and they've become really inexpensive. But it's not always cut and dry. You need to think about, are you going to use the ballast? Are you going to use type A? What kind of, if you have to rewire it, do you have to hire somebody to do it, and that incurs a cost? So there's all kinds of considerations for this. But LEDs are the way that the lighting industry is headed. So some other important considerations, and some of this was in your book, some of this was in the reading, is the color temperature. Okay, so color temperature is measured in Kelvin. So there's technically, you go from 1,000 to 10,000 K. You don't normally see that much variety. The standard that you're going to see most of the time in commercial buildings, you're going to have 3,000 Kelvin, and that's considered warm. Okay, 4,000 Kelvin is considered cool, and 5,000 Kelvin is daylight. So it's a little counterintuitive because the warm, quote unquote warm, is actually the lowest Kelvin, but it has nothing to do with actual temperature. It's the type of light. And so the warm white, okay, so the warm white here That gets you down in this area, so it's kind of like a yellowish, like a real soft color. Whereas the cool white, that's kind of like in between daylight, between white and yellow. And then your 5000K, you're going to get up there. That's daylight, right? So it's like real bright. So different color temperatures are optimal for different applications. So you don't want to have, a daylight, like a 5000 Kelvin lamp in like a fine dining restaurant, right? You want something really warm. You might even go down to like a 2000 or a 3000 Kelvin for that. Whereas if you need to read, something that requires a lot of visual accuracy, you're going to have something that's more on the daylight side of the spectrum. Some other considerations: the lumen output. So the lumen, a lumen is the total amount of light that's output by the lamp. To give you kind of a frame of reference, a 60 watt incandescent is about 800 lumens. And this chart here just shows you the sort of the different wattages of different lights that give you the same lumens. So when you have a 60 watt incandescent, for example, in your house, and you want to replace it with an LED, you get a 60 watt equivalent. Well, 60 watt equivalent is a 9 to 10 watt LED. And as you can see, the 60 watt incandescent gets you about 800 lumens, and a 9 to 10 watt LED also gives you about 800 lumens. So when you replace a light, you need to, assuming the light is acceptable in that room, you want to replace it with a light that has the same, or a lamp that has the same lumen output. Okay. And there are other considerations as well. There's color rendering index and some other things. So some other types of lights that you'll see in commercial applications or even residential. So halogen is actually fairly common in residential applications. This is like an incandescent, except it has this metal pins, and there's a slightly different. It's still, you still have a hot filament in there, but it's a slightly different process. So you'll see these a lot in like little accent lights and task lights and track lights where you sort of pop it in. So that's fairly common, but they're not super efficient. They're a little more efficient than your standard incandescent, but they're much less efficient than an LED or a fluorescent. So in commercial applications, particularly outdoor, you'll see a lot of these high pressure and low pressure sodiums, or HPS and LPS. This was in your book and it was in the reading as well. So these are really, really, really efficient. So low pressure sodium is basically the most efficient light out there, but it's just a crappy light. I mean, it's just not good light. It's really yellow. It doesn't have a great color rendering index, so it's not real sharp, right? So if you look at the image down here, this is high pressure sodium versus an LED, and you can see the LED much more of like a soft, like daylight, natural light. You can see the trees are actually green. Whereas this, everything's yellow. So if you ever go into like a parking lot and everything looks just yellow, that's either a low pressure or high pressure sodium. And they're just older lights that they're efficient and they last a long time, but they just don't make really good light. You will see them out in commercial buildings a lot. So some terminology that's really important to know. So a lumen, as I said, is the measure of visible light. So that's the amount of light that's put out by a lamp. A luminance or illumination is how bright a surface is. It's how much, how many lumens are hitting a surface. Okay, so it's the light coming in, and this is what you're going to use. You're going to measure in your light survey. Two important things to remember: foot candle. It keeps doing that. A foot candle is 1 lumen per a square foot. Okay. Whereas a lux is 1 lumen per square meter. And so it's a measurement of illumination or illuminance. It tells you how bright a surface is or how much light is hitting a surface. Okay, we'll go over that more here in a minute. Luminous efficacy is basically your efficiency, and that is the ratio of light produced to the power consumed. So that's lumens per watt. So you can imagine if you have something that has lumens and a certain amount of wattage, and if you could have the same lumens but drop the wattage, right? You're getting more light or the same light for less power, so it's a higher luminous efficacy, right? So that's kind of your more efficient lights. And different tasks have sort of different acceptable standards for illumination. So this is just a snippet of a table, and there's a longer document in your folder this week. It shows acceptable light levels or illumination levels depending on the application, right? So if we're in a public area like a parking lot, we only need like 20 to 50 lux, which in foot candles is less than 10. Why does it keep doing that? Whereas you have something like a classroom, you're going to need about 250 lux, which is about, say, 240 or 24 foot candles, because there's 1 lux is 0.09 foot candles, or 1 foot candle, or 1 foot candle is about 10.7 lux. All right, so if you take the lux and divide it by like 10.7, that gives you your foot candles. Okay. Whereas you have something like you're in detailed mechanical workshop, you're doing something that needs really detailed work, or like you're an architecture firm and you're drawing, you're making architecture drawings. You need upwards of 150 to 200 foot candles, or 2,000 lux, right? So it just depends on the application, which makes, I think, it's sort of common sense, right? Okay. So how do we measure this? We use a light meter. That's a nice image of a light meter there. This is actually the one that we would normally use in class. And this is the light sensor, and then you can see here just tells you what the the illumination level is at this sensor. So I don't know why it keeps doing that. So what you do is you methodically walk around a room and you measure light levels all over the room to determine, is it an acceptable light level. And what you want to do is you want to hold it at what's called a working level, which if you're at, say, in a classroom, it would be at a computer desk, or at desk level. If it's in I don't know, if you're at an operating table, you have operating level. Whatever the case may be, your workshop, it's your desk level. And then you can sort of sketch it out. So this is a really detailed one, but we can do the one that you're going to do in lab today will be a little more like this. You're just basically going to create a grid, and you're going to take light levels at regular intervals. And then you create like a little map, basically, and then you can say, okay, well, which part of this room is underlit, and you look at the standards to see which, how well lit it is. So for this room, for example, you can see we're hovering mostly between like 3 and 5 foot candles. So if this is a classroom, this is way underlit. A classroom should be about 23, 24 foot candles. Even a parking garage should be about 10 foot candles. So if that's the case, this is underlit. So what you would do is there's some more you would basically determine, okay, there's some more calculations to figure out what type of lights to put in, how much lumens, and so forth, which you may do in a future lab. You install the new lights, and then you go around and you redo this, and you say, okay, now I'm at acceptable levels, or now I'm not, so maybe you have to add more lights. And that's the long and the short of how we're going to do light surveys. So now, hopefully you know the difference between incandescent, CFL, and LED. You'll know what kind of lamps are used in commercial buildings, and you have a basic understanding of how to perform a light survey.